right, Chapter 4, Lesson 5 is compare properties of functions. What kind of things are we going to learn about today? So we're going to compare functions in graph, table, equation, and word form. We're going to review rate of change and y-intercept. We're going to bring back what we learned at the beginning of the school year, and we're going to use it to do these comparisons. Okay? So let's take a look at this real-world link. So what two forms of functions do we have here? We have a function here in table form, right? There's one function. Where's the other function? It's in the equation, right? C is equal to $29.99. So we have a function in equation form, and we have it in table form. And we are going to compare those two functions by answering these questions. First thing we want to do is we want to make a table to represent Carlos's membership. So, after 1 month, how much, or one visit, sorry, after one visit, oh, it's months. Yeah. After 1 month, how much is Carlos paying? $29.99. After 2 months, how much is Carlos paying? What does the equation say? C is equal to $29.99, right? $29.99. Is there a variable in there? In the expression part? That changes the C? There is no variable in there. So since there's no variable in there, it always stays the same. So after 2 months, how much is he getting charged? $29.99. After 3 months, how much is he paying here? $29.99. And of course, after 4 months, it's $29.99. So Stephanie pays per visit, right? So this is Carlos. This is Carlos. And this is Stephanie. Okay? And the question here says, describe the rate of change for each function. So, rate of change. You guys remember rate of change? How do I find the rate of change? All right, so the rate of change is the change in the y over the change in the x. The delta y over the delta x. We learned that a long time ago. All right, so if I wanted to compare or describe the rate of change for each function, okay, for Carlos, the rate of change, the delta y over the delta x, how do I find the change? How do I find how much something changes? So to find the deltas, we're going to subtract. So the delta y, the change in the y's, is $29.99 minus $29.99. Bless you. The change in the x values, 2 minus 1. So when we simplify this, 29 minus 99 minus 29.99 is equal to 0. And 2 minus 1 is 1. So the rate of change for Carlos's function is 0. So to find the rate of change for Stephanie, we're going to subtract the y values, 10 minus 5, over the x values, 2 minus 1. So that gives me 5 over 1. This 5 over 1, what does the 5 represent? Represents what? Cost. That's dollars, right? So that's $5 over 1 visit. Very good. Very good. So here, who pays more for 2 visits? Let's go back up here. Who pays more for 2 visits? Even though if Carlos goes once, or twice, or 3 times, or 4 times, or 5 times, how much is he paying? $29.99 every time. So if he was going for 2 visits in the first month, it would still be $29.99, right? How much does Stephanie pay for 2 visits? $10. So Carlos pays more, right? Very good. So Carlos pays $29.99 per month, no matter how many visits he makes. 1, 2, 3, 4, no matter how many. Stephanie pays $10 for 2 visits. Okay? So, for 2 visits, Carlos pays more. The next question, who pays more for 6 visits? Very good. Because, again, Carlos pays how much? $29.99, no matter how many visits, right? He could go 10 times and still pay $29.99, right? But Stephanie, if we are looking at $5 per visit, for 6 visits, it's $30. Very good. So, for this one, Stephanie pays more. All right. So again, Carlos pays $29.99 per month, no matter how many visits he makes. And Stephanie pays $5 per visit. So for $6, she's going to pay just $30, right? So in this case, $29.99 compared to $30, it's only 1 penny, but still it's more, right? So Stephanie pays more for 6 visits. All right, compare 2 functions. And again, functions can be represented by a table, a graph, equations, or words. You can compare 2 functions represented in different forms. So here, a certain car has a gas mileage of 22 miles per gallon. The gas mileage of a certain sports utility vehicle is represented by the function shown over there in the table. We want to compare the gas mileage. What is the first function in this example? What's the function for the car? So the first function for the first car is 22 miles per gallon. And again, the second function for the SUV is shown here in the table. Okay? So, if I want to look at the rates of change, okay, it says compare their gas mileages. So, this says 22 miles per gallon, right? So, car number 1, we'll call this car number 1, is 22 miles per gallon. So, it's 22 miles over 1 gallon. That is the rate of change, right? For the SUV, we want to look at the delta Y over delta X in order to find our miles per gallon, right? So, I'll do this one in red. And for the SUV, we want to look at the delta Y over the delta X. Now, how am I going to get that information? All right, so The first one is the x value. The y value is the second one, right? And when we put this into our delta y and delta x, we have 3 points, but it doesn't matter which ones we choose. We just need 2, okay? So when we subtract, let's just go ahead and use those 2, okay? So when we subtract, and again, I'm going to keep it positive, so I'm going to subtract the 38 minus the 19, okay? So that's going to go in the numerator. So 38 minus 19 over 2 minus 1. So 38 minus 19 is 19, right? 2 minus 1, 1. Now up here, this is the y value. Which one is the y? Gallons or miles? Very good. So this is going to be 19 miles. And down here, the 1 is the gallons. So the SUV gets 19 miles per gallon. So which one has better gas mileage? The car. Very good. So the car gets better gas mileage. All right. The number of new movies a store receives can be represented by the function m is equal to 7w plus 2, where m represents the number of movies and w represents the number of weeks. The number of games the same store receives is shown in the table. 2 functions. Where's the first one? Very good. M equals 7w plus 2. And of course, the second one is in the table. We want to compare the functions y-intercepts and their rates of change. Now, if we're looking at the y-intercept, what do I remember about the y-intercept? What do you remember about the y-intercept? It's where what? Where the graph. If we look at this equation, if we see y equals mx plus b, the y-intercept is 2. You see that? So, for the movies, y equals mx plus b, the equation was m equals, well actually it's not cursive m, it's just a regular m. M is equal to 7w plus 2. There is my y-intercept. So, for the first equation, the y-intercept is equal to 2. How do I find the y-intercept for the table? Again, we need to know x equals 0, right? We need to know x equals 0. So, here for this one, there's 2 things you could do to find out what x is going to be equal to, what the y is going to be when x is equal to 0. 2 things you can do. So, your second function in equation form is y is equal to 3x. Okay? We want to know what our y is when x is equal to 0, right? So y is equal to 3 times 0. So y is equal to 0 when x is equal to 0. So for the games, the y-intercept is equal to 0.